An empty set or null set or void set has no elements in it. An empty set can be denoted by phi and like this. Examples of an empty set are a equal to x is that x is between 1 and 2. X is a natural number. So obviously between 1 and 2 there is no natural number. So a can be considered as an empty set. B equal to x is that x square minus 2 equal to 0 and x is rational number. If you try to solve this equation x square minus 2 equal to 0, we will get x square equal to 2 and x is plus minus root 2, which are irrational numbers. So again it is an B is an empty set. C says that C equal to x says that x is an even prime number greater than 2. Again we can see that C is an empty set because 2 is the only even prime number. D equal to x is that x square is equal to 4, x is odd. If we just solve this equation, x square is equal to 4, we get x is equal to plus minus 2 and both are even. So D is an null set. A finite set is an empty set or a set which contains definite number of elements. Example of a finite set is A is equal to 1, 2, 3, 4, 5. Other than this definition, the definite number of elements, the set can be called as infinite set. Example of infinite sets are A is equal to 1, 2, 3 dot dot dot. B is equal to 1, 3, 5, 7 dot dot dot. C is equal to dot 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 minus 3, minus 2, minus 1, 0, 1, 2, 3 dot dot dot. Note that all infinite sets cannot be represented in the roster form as they don't have any particular pattern. If we observe these three sets A, B, C, they are infinite because they have a particular pattern and they can be represented in the dots form. A is the set of all natural numbers. B is the set of all odd natural numbers. C is the set of all integers. So we can observe the pattern here in these sets A, B and C. That's why they are infinite. Let us solve a question on finite and infinite sets. Which of the following are infinite or finite? X says that x belongs to natural numbers and x minus 1, x minus 2 equal to 0. So obviously the solution to these are x equal to 1 and x equal to 2. So in roster form we can write x is equal to 1, 2. So it has two elements and it is finite. X says that x belongs to natural number and x square is equal to 4. So if we solve this equation, x square is equal to 4, we get x is equal to plus minus 2. So since x is a natural number, uh, in roster form it can be written as only plus 2. So this is a finite set. The next option is x such that x belongs to natural number and 2x minus 1 is equal to 0. If we solve this equation, we get x is equal to 1 by 2. So it is an empty set. Again, empty set is a finite set. X such that x belongs to natural number and x is prime. So if we represent x as natural number and x is also prime, then we can represent x as in roster form 2, 3, 5, 7 dot dot dot. So this extends to infinity, so it is an infinite set. X such that x belongs to natural number and x is odd. Again, if we write it in roster form, we can write it as 1, 3, 5, 7 dot dot dot. So it is an infinite set. Two sets are equal if they have exactly the same elements. Then we write set A is equal to set B. Otherwise we write set A is not equal to set B. This is an example of two equal sets. A is equal to 1 to 3, B equal to 2 to 1, 3, 3. Notice that we can write B equal to 2, 1, 3 as it is in the roster form, and they have same exactly the same elements, so they are equal. Let us now solve a question based on equal sets. Find the pairs of equal sets if any and give reasons. A is equal to 0, B is equal to x such that x is greater than 15 and x is less than 5. So we can't find any number which is greater than 15 but less than 5. So we can't find any common number. So B is a empty set. C is equal to x such that x is x minus 5 equal to 0. So C is 5. D equal to x such that x square equal to 25. D is plus minus 5. E equal to x such that x is an integral positive root of the equation x square minus 2x minus 15 equal to 0. Let us solve this equation first to find its solutions. Then we can find the elements of this set E. So set E is 5, as we are looking for an integral positive root of the equation. So we can see only set C and set E are equal. Which of the following pairs of sets are equal? Justify your answer. X, the set of letters in alloy, we can write X as A, comma L, comma O, comma Y, and B as L, O, Y, A. We can see they have exact same elements, so they are equal. Let us see the second question. A equal to n such that n belongs to integer and n squared less than equal to 4, and b equal to x such that x belongs to real numbers and x square minus 3x plus 2 is equal to 0. So we can write A as -2, -1, 0, 1, comma 2. And solving for B's equation, we can write x square minus 3x plus 2 is equal to 0. Now if we compare set A and set B, we can see that 0 belongs to set A, but it is not included in the set B. So they are not equal. So we can write A is not equal to B.